Hey everyone, how's it going? Welcome back to Daily Stand-Up. This one I'm going to talk about two prototypes that I had prior to implementing RabbitMQ into my backend. So hopefully this uh, illustrates like what all goes into designing and thinking about a backend system, and how data really dictates the design. So you can see here that this first project is Engines API. And I'm actually not using this anymore, and this is what I had thought I was going to use to begin with. So where I had thought I was going to use this was, I have a two-stroke engines front end project that has a backend controller that requests route through. So the one that is being used is this one right here. Super lightweight post method. All this is doing is publishing the message to my RabbitMQ message queue with using mass transit. So it's publishing it to I think it's what the engines queue, I think it was called, and that's all it's doing. It's not returning any data. It's literally just taking whatever it gets, pushing it to RabbitMQ, and that's it. So that's the sole responsibility, really, of this whole controller. Like I could delete, I could delete both of these. This was literally just for testing. I could delete everything but return view. And that's all I really want this controller to do, is just be my route for this here. So that way, if I want to introduce authorization, I can do that very easily. If I want to introduce any kind of configuration as to how I'm sending the data to RabbitMQ, if I'm using raw JSON, if I'm using the mass transits headers, I can do that. So that's really the reasoning behind that decision. It gives me a lot more flexibility. Now, my original thought was that I was going to go from this send data endpoint over to my engines API. And then my engines API was going to handle all the analysis of the engine data. So again, I'm sending at least like 4,000 to 5,000 messages per minute is like baseline minimum, because depending on the RPM of an engine, that's how many requests per minute I'm going to be making. So that's like, I knew that going into it, but like I didn't, I guess I didn't piece that together fully when I was thinking about this. So I went ahead and made this engines API project, and you can see that I do have a call. If I comment this, I do have a call to RabbitMQ, because I did introduce RabbitMQ into my backend, but then I still try to use this engines API and it just wasn't working well. But my original thought was to use just a service, right? So if we go here, my sync engine data is my engine service, and I would literally just going to pass it through propagator blocks. At the time, I was reading about more functional features in C#. One of which is iPropagator block. Basically allows you to encapsulate pieces of code and then pass data between the methods without having like explicit return. That's really part of what it's doing. So if we follow this block, it's kind of, admittedly, it's kind of a little more cumbersome to read, to be honest. So I created this block factory to basically create each block based off of the interface. So I have a build block method defined in the interface. So I'm just creating the calling that respective method. So if we go into here, you can, whoops, man, Visual Studio on Mac is wild. Like all the shortcut keys are different. It's so in Rider, or Visual Studio on Windows, it's F12 to look at a definition like that, but then it's Command F12 on Rider to go to implementation. Visual Studio for Mac, it's Command I. But even then, I don't know. It throws me off so much. So if we go to engines analysis block, you can see that I didn't actually implement this yet because I didn't introduce the logic there, but I just kind of created the shell for how this is going to be called. And looking back on it, I don't like this at all. It's just so much code to call a method. I don't know. That's the one downside of sometimes designs. They just add so much code to do stuff, and I don't know. Sometimes keeping it simpler is better, just for readability. Yeah, so I didn't actually implement any logic here, but I was just trying to flesh out the shell, kind of for getting the data to flow through. So I created those blocks originally, analysis block. That was going to be temperature. That's what my Rust microservice does. And the save block was going to be, I think I had that initially to save it to a database. But yeah, and then I have it, you link them. So basically the data is going to flow from save to flow, it's going to flow from analysis to save block. And again, it's neat because you don't have to, the data just advances from one block to the next. And then you can encapsulate those. So I have it encapsulated in an iPropagator block. So if we go back to where we built this originally, now we have a contained pipeline that the engine data flows through and is returned. So you can send data through that pipeline, and then you can receive it back. So it's kind of neat because it sets it up in a way that you don't have to call one method, have return type, pass it into another, and then chain it that way. You can encapsulate it into a block. And it also gives you a lot of flexibility for passing in cancellation tokens. It gives you a lot of flexibility for honestly adding logic to dictate which path through the block you want to take. But what I was seeing is that I wasn't really getting much or any performance benefit of this. It was just complicating it a lot. If I was to debug this, it would be kind of a pain, to be honest, compared to just calling methods. So, I would use it sparingly if you're going to use propagator blocks and have a real specific purpose as to why. I thought this was I thought this would have been a good purpose or a good scenario to use it, and the data flow through, but it wasn't working for how fast I needed it to be. So then you can receive it through that. So if we go back to engines controller, you get a result from that. So, but again, you saw how much code it kind of takes to set that up. Whereas if I was just calling a service method and then having calling method 1, 2, 3, it's a lot less code. And you can still achieve similar things if you set it up that way. So again, that's how I was originally looking at it like that. And you can see in my folder structure here, blocks, and then with the interface, and then the propagator with its interface. So I don't know. I mean, have you all used propagator blocks in a production setting, with an honest reason to? I think that's the biggest hurdle for me to actually use this stuff in a real situation. I just don't really feel like I have a good enough reason to use it, but maybe I'm missing something. I don't know. I might try to use it sometime in the real world, but I don't know. We'll see. But anyway, that's kind of what I was originally thinking. So that takes it, again, my original thought was to not even use queues and to just have the backend use it, right? We'll just make another API that can handle it. But again, the biggest limitations to this are I'm using REST APIs and I'm just calling asynchronous methods, right? So, but the problem with that is it's going to be one at a time, right? So I'm going to run out of resources, which happened when you saw that happen on the load test video. Once we hit about 4,000 or 5,000 requests, all my resources dropped. So in a larger scale, I would have to literally just scale the whole server, right? I have to add memory to it, increase the instance size, do something. So again, that's the kind of the hurdle that you run into there. So that was the original plan, and that obviously has been changed for this, right? So now I'm just publishing it to the queue because what I realized is that I don't need to wait for a response for the data, right? I'm not doing anything that requires direct response back for the engine data that I posted up. So this is one aspect of like backend design that you'll probably encounter, is that like a lot of the times your first approach might not be the correct approach for the problem you're trying to solve. And for me, obviously, like I went into it and was like, oh yeah, I'm just gonna make two APIs. I'm gonna create just a service to handle that. It's gonna post it to the database and it'll be perfect. But that's a pretty slow way of working, right? That might not work for you. If you have thousands and thousands of requests a minute, you might have to look into alternatives. For me, the alternative was to use RabbitMQ, and then I threw Rust in there just to make it faster to process the data that's in RabbitMQ. So again, it really comes down to what you need. If you're dealing with millions of requests, you might need something faster. You might need to use multiple queues. And then I used let me show you one other spot where I made improvements as well. So let me go to where is this here? The Q hub. Yes. So that was prototype 2, right? How I changed it to be the singular controller endpoint to pass data to there. And I still have that in my application. You see that I can toggle between using REST APIs and using WebSockets. The current iteration I'm on for the backend is using SignalR specifically to post data to this send message method, via WebSockets, and have that then post to RabbitMQ. And that's proved to be by far the best solution to this. Again, because I don't need response back from that, I just need to post the data somewhere. So again, this is now iteration 3, and I've only got here, through prototyping and load testing. So those are two important aspects. You can't design something 100% beforehand and do no testing or load testing and expect it to be a sound design. I would almost be real skeptical if your first proposal of the design was the correct one to begin with, because it might be a really, really good design, but just in maybe just in another context. REST APIs, .NET APIs are perfectly valid. They work super well. .NET has one of the fastest APIs. You can make some of the fastest APIs in .NET out of anything. .NET APIs are really, really performant. But just an inherent limitation with those is just due to the request response nature, is that they're a little slower. So if you spam them with requests, you'll need to throttle that in some way. Whereas WebSockets, you don't have that same request response, right? You can look at it more of this: I'm now sending data, right? And then it's continuing that sending data to a queue, and then the Rust is then consuming it from there. So this is iteration 3. So again, that's kind of how this whole thing has kind of progressed, and we've seen that. We've done load testing on this. We've gotten it over 1 million messages in a minute and a half with iteration 3. Iteration 4 might be to have the front end specifically just post data to RabbitMQ directly, but that kind of violates some things that I'm trying to adhere to in my system. Meaning, I'm really trying to have the data flow through my .NET backend supporting the front end, just to have that separation there. And I don't need, like, I can do over a million messages in a minute and a half. right? Like I don't need more than that for engines now. But in another context, you might. So you might have to have iteration 4, 5, 6, whatever it is. You might have to explore a host of other message protocols out there, and there's many more that you can try and see what works for you. But again, prototyping is super important. Load testing is super important. And don't be afraid to try something, right? If something's outside the box of like the traditional landscape of like, best practice or whatever, just try it. I mean, you may as well just see what happens, right? If you're getting really good results from a unique and creative design, that's what drives things forward. So I don't know. You can see everything that we've tried in past videos, but yeah, again, load testing and prototyping. You if you load test it once, you should load test it twice just to make sure that you're thinking clearly about it, right? And so all that to say is, I want to show you all this code and show you my original prototype to show you the fact that your original plan or design might not be the final one, right? The first one we had, we load tested it and it crashed essentially, so we had to go back to the drawing board and try something else. So yeah, anyway, that's really what we're kind of getting at here. But I don't view anything I did as wasted time at all. Especially, even experimenting with the propagator blocks. It's a new way of thinking. It's a new way of programming for me, and it might be useful down the road. Whether I use it or not, it doesn't really matter. It just helps you think about different structures of code, in programming. So yeah, anyway, so that's all I got for this one, and I'm going to be continuing working on that one feature I brought up. I made a lot of progress on it the other day. Not going to show you until I get to a certain point on it, but stay tuned for that one. It's coming up. Anyway, I'll see you on the next one.